everyone. We have just hit the 3 o'clock mark. I'm going to go ahead and get started with some housekeeping items before we kick off with the webinar. So for those of you who have signed up today to receive the PDH certificate, I will be sending those out probably tomorrow, since this is a little bit later in the afternoon here for us. So you can expect to get your PDH certificate sometime tomorrow. First and foremost, I want to thank you guys for joining today. This is actually our first ever Lyme 201 session. So big news, you guys are going to be getting some really great content today. So with that, I'm going to introduce our host for today, Mr. Phil Belcastro. So those of you who have joined our webinars in the past, you know his friendly face. He has over 11 years of experience in the materials testing industry, including construction, environmental remediation, soil stabilization, and he has specialized in hands-on testing, method specifications, customer applications, and technologies with limestone, lime products such as quicklime, hydrated lime, lime kiln dust, milk of lime, and other associated materials. So he is our customer applications specialist and our certified in-house expert. So he is all things technical, and we appreciate his knowledge. So I know he's got a lot of really great content for you guys today. Thank you again for joining. And with that, I will hand it over to Mr. Belcastro.
All right, everybody, welcome to another installment of Mintek Resources Presents. Today, like Kendall said, we will be continuing our complete course on Lyme for construction site soils. With our second portion, we're calling it our Lyme 201. Like Kendall said, my name is Phil Belcastro. I'm the customer application specialist with Mintek Resources. I have a little trouble getting to the next slide for some reason. There it is. All right, so course agenda. You see our Lyme 101 there on the side with our check marks. We did that one a couple weeks ago. It is already up and posted to YouTube. If you missed it, you can go over there and check it out. If you can't find it, reach out to us. We're happy to help you out, or maybe even just reach out and do some walk through some stuff with you. Today, in the middle there, we're going to be looking at our 201. We're going to be focusing on the application rates and steps, looking at different DOT specifications and considerations, and lastly, we're going to kind of compare lime versus cement. In a couple weeks, we'll do our third and final portion, where it'll be more of the data, third-party testing, novel projects, case studies, and some frequently asked questions that we've developed over the years. So with that, we're going to do a quick little review of the 101. If you already saw some of this, don't worry, it'll be quick. So Mintek, for over 25, 26 years now, we've been an industry leader known for our service and support, whether that be regional sales managers, logistics team, and more over at our headquarters in Beaver Creek, Ohio, just outside of Dayton, or with technical resources like myself and some others that are even on the call today. Multiple bagging options, usually pneumatic. We've got dump, we've got different bagging. And then I don't want you to just limit your Mintek resources as just construction. We do more than that, so feel free to reach out to us with any questions. We went over Lyme terminology because Lyme is a rather broad term for many calcium-containing materials. Some of them can be differentiated by the presence of magnesium and pozzolans. So we're not talking about ag lime today. That's what you're seeing on the picture on the right. That's just milled limestone, great for the farmers to amend the fields, pH adjustment, add in some calcium, which helps some of the crops, but that's not going to help us in the construction world. We're talking about quick lime, we're talking about lime kiln dust, our calciment LKD, and some of those products. So we got some feedback after our Lyme 101 course that maybe we kind of breezed over some things if we were truly calling a Lyme 101. So I wanted to take a step back and define the term pozzolon. So looking at the ACI website the other day, they define pozzolon as a siliceous or silico-aluminous material that will, in finely divided form, aka small particles, in the presence of moisture, chemically react with calcium hydroxide at ordinary temperatures to form compounds having cementitious properties. So that cementitious properties leads us into our next one, but our quick little fun fact of the day that the term pozzolan actually is derived from the Roman word pozzolana, describing deposits of volcanic ash used by the Romans in Pozzuoli, Italy. Not so coincidentally, that town is not too far from Pompeii. All right, so back to the cementitious properties. So looking back at one of my textbooks from many years ago, cementitious definition is a material that provides plasticity, cohesive, and adhesive properties when it's mixed with water, properties that are necessary for its placement and formation into a rigid mass. So that gets back right to what we were talking about last time, where our calcium helps to form those calcium silicate hydrates, calcium aluminate hydrates, those bonds that have great, develop that strength from that gel formation, the same as when we add water to our Portland cement. And another term that I kind of feel like we should have defined is mellow period. So this one's not coming out of any book. It's basically coming out of the Mintek knowledge here. We're calling mellow period a period that allows for the hydration reaction of quicklime to complete. So sometimes we need a little bit of time where we are allowing the calcium oxide to hydrate into calcium hydroxide. So that is a mellow period. And we'll talk more about that later as far as how long we typically suggest that to be and what happens after that mellow period. Talking about the different products that Mintek has, we're the exclusive supplier of CalCement, a co-product of the lime manufacturing process that has our reactive oxides plus some pozzolans. We've got our quicklime, whether it be quicklime pebble or quicklime fines, and we also have some blending and Portland cement capabilities as well. And lastly, you probably heard me say these three words a couple times last time, probably hear them a couple more times today. We talk drying, modifying, stabilizing, whether it be on the drying side, that hydration reaction where we're chemically combining with the water, where we're eliminating the need for remove and replace operations, helping to increase productivity and extend the working season. The modification, where we are targeting that clay portion of soil, where we're doing some things like cation exchange and molecular flocculation and agglomeration, if you remember those terms. All that's going to result in reduced plasticity, improved compaction and stability. We're going to lower that shrink swell potential and give some increased bearing capacity. Don't forget about the net effect between drying and modifying. We're going to decrease that maximum dry density, making compaction easier. We're going to increase that OMC so we can accommodate more moisture at the time of compaction. Lastly, on this slide, on the stability side, or on the stabilization side, excuse me, those are the reactions from the pozzolan-rich environment. We talked about that term already, to form those cementitious bonds over time. So our high pH associated with quicklime, we're going to solubilize those pozzolans that are in those clay materials, or we're going to bring them to the table with our CalCement LKD, form those same bonds I was talking about before, the CSHs, CAHs, and we're going to get some great strength over time. We're going to form a nice solid monolith, lower the moisture, give better freeze-thaw resistance, and have some strength gains that continue to grow. And we'll talk more about how they grow a little bit later. And lastly, I want to point out that we have that potential for reduced pavement thickness. We're going to minimize the need for virgin material, saving everybody money. So we like to tout that the right product for the right project. So this is a nice little tool. I'll pop this up a couple times today when we're kind of highlighting different areas. We have nice laminated copies of this that folks like to have out in the field, stick on their notebooks. But it's helps to kind of show what products are good to use where. We'll point our attention to the bottom real quick, where we're talking about soil drying. All day, every day, the CalCement, the quicklime, the increased available lime content of those are your best drying option. And then on the modification stabilization side, as that plasticity index and clay content increase, so as we move further and further to the right on this table, that's whenever the lime products really are a great option for us. Quicklime and the fatty stuff, the fatty clays, and the CalCement bridging the gap between the more granular soils that are more conducive to cement and the lime conducive soils, the fatty clays. All right, thanks for bearing with me through that. on to the meat of this one. So application steps and doses. So on the dosage side, when we're trying to dry or modify, typically our range is anywhere from 2 to 5%, depending on what you're trying to do. If you're just trying to dry your soil, dry your site, get back to work, we're not going to wait around for lab tests, right? We're going to throw some lime on that soil, soak up the water, and get back to work. If we need maybe another percent, go ahead and throw that down if it's not working, and then use that moving forward. On the modification side, there we're seeing, we're looking at some of the Attenberg limits. We're seeing how we can change the PI, the classification, etc. Remember, we can make an engineered fill essentially with that lime treated soil. On the stabilization side, typically a higher dosage rate associated with that, 3 to 7%, but really usually around 4 or 5%. But we need to make sure we have the right amount of lime in there, the lime fixation point. So, going back to our lime days, or our lab days, excuse me, ASTM 6276, the EADS Grim test is what we use in the lab to make sure we're getting the right amount of lime in that soil. And then real quick on FDR, anytime we've got thin asphalt overlay over top of a clay soil with limited, minimal to no aggregate base, that's whenever the lime and LKD options can be good for us there on the FDR side. 4 to 7% depending on your mix design. So the application steps. Typically, we're going to load our material out in a pneumatic tanker, but we also have other options like dumps and super sacks and things like that. So the folks in Beaver Creek on the logistics side are really good at getting things where they need to be. Then we're going to transfer it to our spreader truck. That way we can get it out at the nice rates we want without having to get that pneumatic tanker out in the field. Louisiana side, they do things a little different. They've got a spreader bar on the back of some pneumatics sometimes. But hey, then we're ready to spread at our designated rate. Not sure what rate you need? Well, we can help. Our sales guys can help. We can reach out to myself, or you can take a stab at it. We have our dosage rate calculator that's live online. But like I said, very happy to help. If you want to take a look at this, it's a pretty cool little tool, but please reach out to us. We're happy to help. So after we've spread our lime, we got to combine with the soil and water if needed. For the quicklime, we need to make sure we're quenching that hydration reaction that we talked about before and get ready for a little mellow period. But before we talk about mellow, just want to point out real quick that those reclaimers are the best way really to incorporate. Some folks use excavators depending on site conditions or what you're trying to do, but really those soil reclaimers are really good at getting a nice homogeneous mix for us in that soil. So it's definitely preferred. Back to the mellow period. So we had talked earlier about how there's a need to be sure that the hydration reaction has run to completion. So we typically say about 4 hours is a good mellow period to allow that to happen, and get on it with a second mix to make sure that there aren't any just pockets of hydrated lime or unhydrated lime that needs exposed to some water. So we recommend 4 hours. We've seen people do it a little bit quicker, but like I said, a recommendation is 4 hours with the second mix to make sure you're utilizing all of the product that has been delivered to the site. Next, we're going to compact at our predetermined maximum dry density and OMC. And a little callback here to Lime 101 session. Remember that we have to target that new Proctor curve because we have changed, we've modified that soil. So we got to make sure we're hitting the right targets in the field. And once we've done that, we're ready to grade it to our cross slope requirements and get our smooth roll on it. So the steps: transport a pneumatic tanker, going to then transfer it to our spreader truck, spread it at our designated rate, combine with soil and water if needed, compact it, grade it, get our final smooth roll on it. All right, Zooming right along. And take a dive at some kind of broad DOT recommendations, specifications, considerations, things like that. But DOT approvals, excuse me, rest assured that we're working in your area. We're on those DOT QPLs, the qualified product list. We're working with the DOTs in your area. So if you're working on a DOT project, feel free to get us involved. Actually, please get us involved. We'd like to make sure things run smooth for everybody. Those typical specifications are found in these sort of sections of those books. Standard specifications for road and bridge construction, and oftentimes we're under earthwork, subgrade, and some material sections. Mixed designs, once again, get us involved early. Lots of DOTs have these specifications that the testing's got to be conducted by an approved geotechnical consultant. So let us get into contact with them and work with them. Lime can be a little bit finicky sometimes, so we can help recommend labs. We can work with labs. We do some testing to prove out our products. Some other things to consider. Change orders and things need to be done days in advance. So once again, get us involved early, because that quantity or the recommendations by the DOT need to be made in advance. Once again, got to be on the source of modifiers. Hey, just call back to that slide right before this. We're on those lists. As with anything, there are often limitations. Lots of them have temperature limitations, or at least ranges where you can't work anywhere from below 35 up to 45 degrees Fahrenheit. 45 is definitely a stretch for me. And it can't be mixed with frozen soils or soils containing frost. So once again, really broad DOT specifications here, and I understand why they did it, but believe me, we've worked in those situations, those conditions before. If you're not under the DOT umbrella, those restrictions, if you will, reach out to us. We've got a whole cut sheet on cold weather liming. We've done webinars on cold weather liming. We've been out there in the cold weather. We can help to extend that working season and keep the work moving. Can only be performed in areas to be paved during the same construction period. I like to point this one out, that lime stabilization is a great thing, but you can't expect it to last forever if you don't cover it and continue with the process. So you can't treat an area, leave it exposed, and expect it to last through the winter and be ready to go next spring. Not going to be the way it's going to work. So just to keep that in mind. Move along, preparation, nothing really earth-shattering here. We've got to remove those large aggregates, usually about anything larger than 3 inches. The moisture every blank hours, 4 is a good standard, and the OMC has got to be maintained for 48 hours. So once again, pointing out, hey, we got to make sure we're hitting that modified OMC, the right target in the field. Mixing, get a nice homogeneous gradation. The soil reclaimers, obviously preferred method to do that, and can rip through that stuff, no problem. Compaction, here's kind of a standard DOT spec where lime, you got to get it compacted within 24 hours, whereas the fly ash, the cement, got to get going on that stuff quick. Once the water hits it, going to start hydrating. And there's some other application advantages that we'll dive into a little more later. All right, on to the lime versus cement. We're faster than cement at drying. I mentioned it earlier. If you're in a drying application, just looking to get out of the mud after a couple days of rain, all day, every day, the high calcium oxide content of both the calcement LKD and the quick lime are going to outperform the Portland cement across all soil types. So those 2 circles down there with the green bar and the explanation, it's the best drying option out there. It's going to draw that moisture from the soil. It's going to produce that exothermic reaction that's going to release a significant amount of heat that's going to drive off the additional moisture in the form of steam and evaporation. So if you want to see a nice example of that impressive exothermic reaction, we got another YouTube video out there where I'm actually frying an egg with some lime and water. So kind of a cool one. If you got a couple minutes, want to check that one out. So once again, all soil types, no matter what we're trying to do here, if we're just trying to dry the site, take something like this to something like this within hours. On the modification side, here we're talking about as we target the more clay soils, that's where the CalCement LKD and quicklime can really have some benefit for us as those situations arise. We can reduce that plasticity index. So in this chart, the larger the bar, the better. We're talking about reduction in plasticity. So the larger the bar, the greater reduction. Versus control or untreated is what we're looking at here. So the black bars are a high plasticity soil, high plasticity being greater than 20. The gray is a medium plasticity soil, 10 to 20 PI, and then we did some tests on low plasticity, less than 10 PI. Those green bars, that's low plasticity, you can only reduce it so much, so not a huge difference there, but as that plasticity increases, you're seeing a greater and greater drop in that plasticity. Really good for us, right? Now, there's no rule of thumb to know how much material you're going to need to reduce that plasticity. You'll drive yourself crazy trying to correlate. You need to do the lab testing to determine. There's no silver bullet equation to figure out how much you need. Get us involved. Let us do the lab testing, prove out the products. Excuse me. So that modification is going to once again increase that optimum moisture content, less effort to hit the compaction, and can be done at a higher moisture content. Going to reduce that shrink swell potential. We talked before about how that molecular flocculation and agglomeration in the Lime 101 session kind of makes room for the extra water that might enter the system later. Going to give us an overall improved working platform. Going to increase that optimum moisture content. We've talked before in the 101 session about how we're shifting that. There's the net effect where we're shifting the optimum moisture content and dropping the maximum dry density. And you can see how the lime products kind of line up to the cement and the untreated material. So we'll talk about strength gains that continue. Excuse me. So those strength gains are going to give us better long-term results, lower dosage rates, and some other great results. And this is a cool study we did at the Innovation Center where I'm based out of in Pittsburgh, where we did a year-long study with, I believe it was 10 different soil types with a varying degree of plasticity, and see how they performed over a year. So we got 7-day marks, 90-day marks, 28-day marks before that, and then the 365. And you can see that the lime treated soil is more of a marathon runner compared to the sprinter that is Portland cement. We all know what cement does. It's great at forming those bonds, but those bonds form quick, which is good sometimes, but they kind of taper off over time. Whereas lime, if the reaction, all the ingredients are still there, the reaction can continue over time. So it's going to react with the natural pozzolans in those clays or supplemented with the CalCement LKD, which can allow for some lower dosage rates to achieve better long-term results compared to the Portland cement. So last slide was strength gains that continue. This is kind of a last minute one I threw in there because I just love the term. Strength gains that heal. Well, what am I talking about here? Something called autogenous healing. A couple cool studies out there, one from 1969, another one that was done in 2007, that just kind of points out that basically as long as there are the ingredients still present, if something happens, if it breaks, say because of freeze thaw, that the strength can actually come back and continue over time. So pulled out some things from these studies that lime treated soils continue to gain strength or autogenously heal because the necessary reactants are available. And on the other hand, Portland cement generally consumes all of those cementing agents right off the bat. So that autogenous healing is just a really cool thing that is kind of one of the application advantages that the lime products have. It's a little more forgiving. If something should happen in the field where the quick lime is not hydrating right away and those bonds are forming. And if you break them, they're done. They have time to heal. And this is exactly what that DOT specification that we saw a little bit ago is hinting at. That, hey, we don't need to get things done right away as that hydration reaction is going. It's much more forgiving. So it's not as time sensitive where we just talked about, must be mixed and placed in a couple hours, where quicklime and calciment can really be placed over a day after application. Oftentimes we have people that essentially make an engineered fill that we've talked about. They'll treat the material, they'll stockpile it for later use, and they can get bring it back to where they need it and place it, and still expect to get not only the modification that happened immediately, making an engineered fill, but really can get some strength gains. We can extend the working season. So you saw some pictures of us working in the cold. We're going to generate that heat as it hydrates. That heat is capable of driving the desired chemical reactions, even in those frozen soils. And we can actually thaw out some of that frozen soil, making that water now available for the hydration reaction that is needed for the quicklime. So with that, pretty quick session here. That's our 201 in a nutshell. We talked about our review. We did our application rates and steps, looked over our different considerations and specifications, and something quick on the lime versus cement. So remember, come back next time where we get more into some of the data. It's a pretty cool, we have some pretty cool case studies and projects that we call out, and some third-party results that we'll look at as well. And remember, if you attended the first one and you're at this one, not watching the YouTube video, if you attend all 3 sessions, you are eligible for what we're calling a swag pack. Nice polo, a hat, and an Amazon gift card. So mark your calendars for July 19th, just a couple weeks from now. And we will continue with the 3rd and final session of our complete lime course for soil treating construction site soils. So with that, we'll open it up. We can see if any other panelists want to chime in on some of the questions, if there are any. And with that, we'll, like I said, open up for questions. Let's see if there's anything in the Q&A. Kind of let me know if you see anything. I see no open questions at this time. So feel free to write some in the chat box. If not, get them to us later. We can add them to our frequently asked questions for next session. Give it a couple minutes, see if anyone wants to chime up.
First question is always the hardest. Everybody waits for somebody to open the door.
All right, staying pretty quiet. Like I said, shoot us an email if you got something you want us to maybe hit in the last session. If you got a question that's just been bothering you or something that comes up in the next couple weeks, let us know. Thanks for joining. Short and sweet one here. Here we go. What's the most common question you received? Man. Let me think on that one. Got another one. Is there a way to go back and see the 101 course? Kendall, you can speak to, but I mean, you do a quick Mintek, Google Mintek resources and YouTube, and our channel will come up, and the Lime 101 session is up there. Kendall, you got any tips on how to get there? We can send
I can send the follow-up link in the link to the 101 session in the follow-up email though.
Yeah, thanks for asking, Mark. What happens if you mix with lime, then try to compact after 24 hours? I think what you're getting at is we said we had that 24-hour threshold where we like to compact within those 24 hours. It's not like it's going to turn to a rock in those 24 hours. Lime is very forgiving. I wouldn't recommend waiting too much longer than that, but it's not going to be turned into a rock on you at that point. I would hasten to say that you will be okay, but if anyone else wants to chime in, I saw Brian's on. Dale, if you had Dale, Jim, Rob, any experience out there that you've seen, I think you guys can come off mute if you're able. If you can't, maybe start typing. If not, Mark or Preston, excuse me, I can get back to you with a firmer answer if someone else has something to add to that. Looks like Dale might be trying to talk. He's muted. Kendall, can you?
Yeah, let me see if I can.
Dale.
There we go. You should be able to have the option to now.
Okay. Yeah. Good afternoon, everyone. So yeah, the one of the things about lime that is more forgiving than cement is the fact that we do say you have flexibility with your compaction. And what we mean by that is that there's a lot of applications, particularly when we're doing embankments and we're building up material where we're going to stockpile material that would normally not be very suitable. But by adding the lime to it, we're changing the engineering properties of it in a stockpiled situation and then able to bring that material over and compact it at a later time. That level of convenience is one of the advantages to using lime. As long as the material that is mixed with lime is not exposed to water, we have seen days where we can stockpile materials, or if it's covered in some way, or if it's compacted loosely with a drum roll compactor where water can shed from it, you can then go back and use that material for days after. We haven't done any testing to say weeks, months. I imagine over time you're going to get some loss of some of the pozzolan strength because you will be getting some of the pozzolan growth. But because it's slow acting, I think I'm very comfortable in saying I've seen it, stockpiled material be used for days and days after it's been mixed. Again, the precaution there is just to make sure that it doesn't get exposed to any inclement weather.
Thanks, Dale. That was a good call. So I think a quick summary is, yeah, put some compaction on it, put something on it to shed that water, get it off the material. I'm not seeing any more questions come through. Appreciate the ones that came through. Join us next time. With that, I think got one coming through. Hey, Dane. Can you revisit the importance of thoroughly mixing lime products into the soil? What are some potential issues that happen if it's not thoroughly mixed? So I'd say absolutely important. Use those soil reclaimers. If you don't mix it properly, you could potentially have pockets of unhydrated material that if you get compaction on it, eventually water is going to find its way to that and it is going to hydrate. When lime hydrates, it's almost like popcorn. It expands and it could break that compaction. It's got some force behind it. So Dane, I think that's what you were kind of getting at, is make sure you're getting that good mixing action to be sure that everything is properly incorporated, and once it's incorporated, we're doing more testing right now to see about that mellow period. 4 hours is a good threshold with a second mix, especially when you're using the quicklime fines, that being 3/8, realistically more a 1/4 inch by 0. That material will hydrate within those 4 hours, especially with the second mix, to eliminate any possibility of loss of compaction. So I'd say that's the important part. Use the reclaimers, get that mixing, make sure it's well hydrated at OMC, maybe 1 to 2% above, to be sure we got enough water. So yeah.
We have a couple more that have popped in too. I want to backtrack one to Carl's question. What is the criteria for using lime and FDR application? Do you see that one in the Q&A box?
I do.
Okay.
Hi, Carl. FDR applications, I think this is where the calciment LKD is really a good option, because with the FDR, you're mixing in and getting, some, maybe not compaction right away, but the calciment LKD, there is no mellow period associated with that, and it tends to be better for the FDR. Let me reread your question. how much subgrade / clay soil is needed to incorporate into the FDR mix to be effective. Depending on your criteria, I know it's kind of open-ended, but if you're kind of picture the the country roads, if you've just got a thin asphalt overlay that's sitting on top of the clay soils with hardly any aggregate base, so you're really incorporating some of that clay material where we can go in and get some strength with that. I think that's where we can really be effective, is when you're incorporating a lot of clay soils. I don't know if Dale or anyone else has anything to add to either Carl or Dane's questions. Thanks, guys, for bringing them up, by the way. And I'll read the next one that came through with Mark. Yeah, Dale brings up the Virginia used LKD in their highway. There was a huge project that brought folks from all over the world a couple years ago, whenever FDR was first coming suit. And Jim, if you're on, Jim's our regional sales guy, manager in the Virginia area. And Jim, I believe you were on that job, but they used both Portland cement and the Cal cement LKD on that project, and they got some great results. Jim, I saw you just came off mute. Looks like if you want to add to that one, feel free.
Can you hear me?
Yeah, I can hear you, Jim.
So are you specifically speaking of the I-81 job?
Yeah, that's the one that popped in my head when Dale brought up that Virginia used LKD.
It was a really unique project. It was, to my knowledge, one of the very first and only, first projects, FDR on a interstate highway. It was done over here in Virginia. It's basically what they did in their particular case. They milled out all the asphalt all the way down to a very small section that still had some stone subgrade anyway, probably there was maybe 3 or 4 inches of stone, but then they pulled up into that mix probably another 8 or 9 inches of clay and mixed in cal cement with that. The cement that was used on that project was used on the fast lane, if you will, the passing lane on the left, and that was a whole different process. That was not even FDR, but cal cement was used on the I-81 on the truck lane, if you will. And again, they milled off all the asphalt and a lot of the stone, and then when they got down to a certain amount of stone and more clay soil, they incorporated the cal cement into that profile, if you will, compacted it, and then they came back with the asphalt, layer, if you will. And yes, there is a paper available. There's probably tons of them actually, that you can just go to the, I think it's called the BDOT Research Council. You can probably find some things that were written by Brian Diefendorfer that should be real informative and as to what the process was and how they did it, particularly on the FDR side. Again, they did a more of a, I can't remember exactly what they did on the other lane, but it was just a totally different process.
And we do have,
but it involves cement.
we do have on a much lesser technical level a case study that's available on our website for that project as well.
That's true.
Looking back through, I think we touched on all of them. The last one I see is from Mark. Does lime raise pH more than Portland cement at the same dosage rate? That's a good question. I'm actually not entirely sure. Dale, do you know exactly if?
Yeah, so cement and lime both have free lime in it. So with enough cement, you could achieve a pH of 12.45, just like you would with lime. So if the dose was very high, theoretically, you could hit the same pH, but in reality, the answer is probably no. The free lime will get used up very rapidly through the chemical reactions that take place as cement sets. It will raise. You will be above 10, probably closer to 11. Where quick lime, being that it's 90% calcium oxide or greater, which is what's really driving the alkalinity, will reach a 12.45 state, which is actually what we want to see happen, because that's when we solubilize the aluminous in the silicates. So theoretically with enough, yes, but the real answer is in most applications, the answer would be no.
Yeah, so that free lime in the cement, most of it's used up in its own hydration reaction. So just one other thought, kind of open up for discussion a little bit. I saw a list here. I know where some of us are from. I recognize some of the names, but anyone seeing cement shortages in the area? So just kind of point out that sometimes lime can be a substitute, especially if we have the calciment LKD available that bridges the gap. But even the lime could be a substitute, so something to consider, because we are hearing and seeing those cement shortages. People being put on allocation and that allocation being adjusted very rapidly. So something to consider. If you got cement jobs, talk to us, get some samples to us. We'll see if we can, if lime can be an option, especially if you don't have cement as an option. All right, appreciate the questions that came in. Starting to die down a little bit here, so reach out to us if you got anything on that last comment about the cement or anything else, really, any other questions. Be happy to address them. Get back with us on, Kendall, do you remember the date? I believe it's the 19th, July 19th.
Yep.
Yes, they're 3 weeks from today. We're doing more of the data case studies and some of those frequently asked questions, which I can get back to. What was that very first one we had? Someone said, hey, what's your most common question? I don't know, just to wrap up, Jim, Brian, Dale, what questions have you guys heard over the years that kind of is the one that's recurring? I could think that mellow period would probably be one that I see, why, how long, 4 hours, second mix. If you can plan it, so you're mixing over here, mellowing here, and just kind of operations continue that way is the way to go. But if anyone else has any comments on that.
For me, it's always, how much does it cost? And I direct it to the salesperson.
Yeah, I do love those questions. Sorry, Jim. Rob is on here too. You're welcome, guys. Thanks for joining. Please join us next time. Hope you're enjoying them. I know we're enjoying putting them on, so join us next time. Looking forward to it. July 19th, same time, same place. Bye.
Thanks, everybody.